only going to go back to the universe when it was maybe a billion and a half years old, even with James Webb Space Telescope. We do have the measurement of the cosmic microwave background. So that is one measurement. Looking at the galaxies and how they trace sound waves, it turns out we can also use that back to probably more distant than we can use the supernovae. But we're always going to struggle with the dark time of the universe, before there were stars, before there were galaxies. Nothing we're going to measure much easily there, I'm afraid. So we're always going to have to be content that there's that part of the universe we're not going to be able to study very easily.
Okay, a question at the back.
Hello. Thank you for your talk today. I would like to know more clearly why it is, if dark matter only interacts with things through gravity,
Yep.
what is it that makes it that we assume dark matter is a type of matter and not an aspect of the force of gravity that we don't understand?
Yeah, so that's a very good question. So imagine that it's just gravity not behaving quite like I expect. It turns out that you can do that, and you can make it look and make it work just like a particle. Why would I want it to work just like a particle? Because when I look at the sound waves, and I'll show this oscilloscope. If you go through and say, let's presume it's a particle that doesn't interact with itself, you get exactly the right answer. So when you predict something in advance with an idea, that usually gives it credence. Now, it is true that I can take the laws of gravity and reproduce this after the fact, but I couldn't tune it before the fact. So what's right? This comes down to a fundamental piece of the philosophy of science. The simplest thing we have right now that predicts what we know and what we observe is how we think of the universe. Right now, the particle idea is a better predictor than the gravity idea, because every time it makes predictions, it gets the right answer, where we have to keep tuning the change of the modifications to gravity to get them to make the right answer. So it's really a matter of simplicity at this point.
Okay, more questions? Well, there are two. Maybe the female student?
Hi, I don't actually have a very nerdy question, but my question is, what prompted your interest in astronomy, and why are you passionate about this field?
Okay, that's a very good question. So I think when I go out and talk to 10-year-olds, I've yet to meet a 10-year-old who doesn't find the sky and stars and astronomy at least a little interesting. So when I was 10, I became interested in astronomy, but I was really interested in meteorology, the study of weather. I was very sure I was going to become a weatherman. So when I was 16, I went and worked at the weather department up in Anchorage, Alaska. And it wasn't quite what I was expecting. And so suddenly I said, my goodness, what am I going to do when I go to university? I said, well, I like astronomy. It's interesting. It's not very useful, and I'll never get a job doing it. But I don't know what to do, so I'll do it anyway because I enjoy it. And I'll figure something else to do with my knowledge later on in life. So that's how I became an astronomer. I never did think I would actually become an astronomer, but I knew by doing astronomy and something I enjoyed, I'd learn math, I'd learn computer programming, I'd learn engineering, I learned physics. And I knew those would be useful skills. And I was right. The skills I got in being trained as an astronomer, I could be doing any job on planet Earth almost. Not a ballerina, but anything, you know. Not a musician. Tried that, didn't work so well. So that's how I did it. So my lesson in life for people is do something that you enjoy, you will do it very, very well. And normally things figure themselves out. One thing I can promise you is over the next 50 years, things are going to change so much is that if you think you can predict what is the right thing to study right now to ensure that you have a job 30 years from now, you are a fool. Because I have no idea what things are going to be like 30 years from now. So I would encourage you to do something you enjoy so you do it very well. And doing things well make you skilled at what you do. And that will be useful later on in life. Learning how to solve problems and do things that you love. Eventually, sometimes you have to do things you don't like, though. Just as a warning.
Okay, there's another question just over there.
Thank you for the excellent lecture. So during your lecture, you also talked about the expanding universe. So I was wondering, since it's continually expanding, where do you think the universe is expanding to? And I also have a second question.
Yep.
So you also mentioned that dark energy is constantly being generated. So I was wondering if at one point in the universe, it could be constituted of, say, 99% dark energy and the other parts being very negligible in the composition of the universe.
Okay, so what is the universe expanding into? This is a question which I didn't go into in as much detail today as I do sometimes. But in Einstein's theory of general relativity, space, this way, that way, that way, and time are connected. So one of the possibilities is that the universe is infinite. So infinity just gets bigger. So that's analogous to having a number line where you've got 0, 1, 2, 3. You multiply by 2 and 0 stays where it's at. That's where you're at. 1 goes to 2, 2 goes to 4, 4 goes to 8, 8 to 16. Infinity goes to 2 infinity, 2 infinity goes to 4 infinity, and thereon. So in some sense, that's just part of being infinite. And infinity I'm not going to make you comfortable with, unless you're already insane. It requires a certain level of insanity to become comfortable with infinity. But the universe might be finite. That is, space might bend onto itself, and I didn't talk about that. In which case, the easiest analogy is to think of the universe as a balloon. But it's a balloon in 4 dimensions, not 3 dimensions. So the Big Bang is when the balloon is not blown up. And as I make and I blow the balloon up, the balloon becomes bigger and bigger and bigger. Where is the Big Bang? Well, it's everywhere, but it's back at the center, at the beginning of time. So as I blow the balloon up, you're moving out in time. The universe is becoming bigger and bigger. Where is the universe going to go in the future? It's going forward in time. So it's expanding into the future. So there's an analogy that you can stay awake for tonight.
Okay, maybe last question here.
Professor, thank you for your wonderful lecture. I have 2 questions. One of the best philosophy of China history, Xiong Li, he also constructed a universal model according to the Chinese classical Zhou Yi. He think about because the competition of the yin-yang, the negative force and the positive force, so the universe will expand and then collapse.
Yep.
Then expand and then collapse. I think his theory is very beauty and symmetry.
Yep.
According to his theory, now the universe is accelerating, expanding. because I think because the dark energy, the positive force is stronger than the negative force is stronger than the positive force. So now the universe is accelerating, expanding. But this situation only one part of the whole universe history.
Yep.
And can you evaluate his theory? Okay.
So let me just explain.
Okay.
So science, and the way science works, is that you have a series of essentially mathematical laws which you make predictions from a very fundamental basis, and you have to predict lots of things. You have to predict the apple that falls off the tree. You have to predict Halley's Comet's orbit. You have to predict how atoms interact with each other. And you have to predict that all with one giant physics theory. So in the case of what we're doing, we make predictions, but there is finite information. And so we don't claim to be able to predict with absolute certainty the future, because we could only do that if we have absolute information. So if you look at ideas that you've just talked about, those are ideas based on aesthetics, I would say. And in the same way, I find a universe that you've just described aesthetically very pleasing. I really can't easily predict anything with it. So that is an area of metaphysics. It's different, okay? In the same way, when I talk to people about their view, when they ask me, is there a multiverse? Are there other universes out there? Right now, I can't test that idea. I don't know. Aesthetically, I think there might be, but that's a metaphysical statement, not a physical statement. So I think that's the only answer I can say. I realize that I forgot to answer one of the questions here, if that's all right, before I forget. You asked the question, can 99% of the universe be dark energy? And the answer is yes. In the future, our prediction is in about 30 billion years. In the future, the universe will be 99% dark energy. And then another 30 billion years after that, it'll be 99.9% dark energy. Another 30 billion years after that, 99.999% dark energy. And it just keeps on going on and on and on. That is, as it fills up more in the universe, it gets bigger, we become less and less important. And in the very, very distant future, it may well be that every elementary particle in the universe has its own infinite universe it lives in. So there's one elementary particle per bit of universe, all by itself. So that would be a very lonely universe indeed.
Okay, Professor Schmidt has to fly back to Australia right after this lecture. So let's thank Brian again.
Thank you very much, everyone.